Hi everyone. In today's lesson, we're going to talk about a concept called Law of Cosines. Law of Cosines allows us to find angles and sides of a triangle, more specifically though, when the problem includes three sides and one angle. Here's the formula that we're going to use. So you'll notice that there's the three sides, A, B, and C. Those are your lower cases. And then there's one angle, angle A, right? So it has three sides and one angle. Side A, B, and C, and capital letter A for the angle. Now, it's important to note that A is the included angle inside angle side, and I'll explain what that means in just a second. So let's look at example number one. So they've given us triangle ABC, where side B is 12, side C is 20, and the measure of angle A is 40 degrees. It looks like there's a typo here. This should say 40 degrees. So it says find side A to the nearest integer. So right here is the side that they're looking for. All right, so let's start by writing down the formula for law of cosines. Okay, so first I need to make sure I understand why I can use this formula. So up here we wrote that law of cosines, I can use it when the problem includes three sides and one angle. So side, 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 and an angle. Obviously one piece has to be unknown, so it happens to be this side, that's okay. So as long as there's one, two, three sides and an angle with one thing being unknown, then I can use law of cosines. All right, so the next thing you want to make sure you look out for is that the angle that's given A and the side across from it goes here, right? Because the relationship between capital A is the angle, lowercase is the side. So A, we're going to leave as A squared. B is 12. And C is 20. And then again, plug in 12 for B and 20 for C. And cosine of the angle this here is 40 degrees. So honestly, this is actually super easy to do. We need to solve for A squared. If you notice, there's no missing terms here, so you can actually plug this all into the calculator just the way you see it. So that's actually what I would like everyone to do right now. I would like you to take out your calculators and plug this in just the way you see it, and then hit resume when you're ready for the answer. Just make sure that your calculator is in degree mode. If you are not in degree mode, you will get the wrong answer. All right, so go ahead, pause the video, and come back when you're ready for the answer. Okay, so I got 176.2986673. And that's what we solved for A squared. So if we want to get A, we're just going to have to take the square root of that. So if you want to pause the video, go ahead and try to see if you match up with what I get. When I take the square root, I get 13.277. It does go on for longer, but they're asking to round to the nearest integer, so that just means the nearest whole number. So if you want to write whole number, that's fine, is 13. Perfect. That's how we use law of cosines to find a side. Now, sometimes the triangles won't always be A, B, and C. Sometimes you might have a triangle that says DEF or CED, whatever the letters are. But the formula is not always going to be the exact way that you see it. So let's look at question number one here. I'd like to work on manipulating the formula. So here we've got another triangle. Again, it's ABC, and that's okay. Little a is across from angle A, so that can go here. Little b is across from angle B, so that can go here. And little c is across from angle C, so that can be there. And they're asking us to find the measure of angle C. So first things first, I know I can use law of cosines because I have three sides and one angle, and something is unknown. So the formula, I'm just going to write it down, is a squared equals b squared plus c squared minus 2bc cosine of a. So in the problem, we only have one angle. Here is the angle that we have, and this is the side that is across from that angle. Right? Because that's the relationship between capital A, the angle, and its side, lowercase a. But if you look in this problem, this is the angle that I'm given, which is angle C, right? And the side across from angle C is 7. So in this formula, what's going to happen is we're going to set it up with C squared coming first, because that's the side across from the angle that's given. So now I have C instead of A. So it's C squared equals, and now the other sides are just interchangeable. So A squared plus B squared minus 2AB cosine of C, right? The angle that's given and the side across from it. So the formula will always be different depending on what they're asking you to solve for. All right, let's do one more. So here we've got triangle DEF. Little d is across from angle D, is radical 3. Little e is across from angle E, which is 4. And the measure of angle F is 30 degrees. And they want us to find the length of little f, which is here. So similarly before, we now have here, this is angle F, and this is the side across from it. So I'd actually like you to pause the video and see if you can come up with the correct equation with using letters D, E, and F, and then hit resume when you're ready for the answer. Okay, so since the angle that's given is here and the side across from it, we know that that has to go here and here in the formula. So lowercase f squared, and then we have the E, which is the other side, and D that we can interchange. So E squared plus D squared minus 2ED, and then cosine of capital F should be your answer. Excellent. All right, let's take a look at the next page. And let's try example number 2 now. So it says, find the largest angle to the nearest tenth of a degree in a triangle whose sides are 9, 12, and 18. So we need to take a page out of geometry's book here, and we need to remember that the largest angle is across from the largest side. If they were asking for the smallest angle, it would then be across from the smallest side. So here we know the largest side is 18, so the largest angle is here. They're asking us to solve for B. So what we know from before when we're setting up the formula, the angle that's given or needs to be found is here, and this is the side that's across from it. So when we set up the formula, it's going to be B squared equals A squared plus C squared minus 2AC cosine of capital B. So let's plug in what we know. Little b is 18, so we can go ahead and put 18 squared. Little a is 12. Little c is 9. And then I'm going to just put in 12 for a again and 9 for c. And they want us to find angle B. So unlike the first problem that we did, we unfortunately cannot put this all into the calculator in one shot because the cosine of B has an unknown. So what we can do is we can start by squaring some things. So we know that 18 squared is 324. 12 squared is 144. 9 squared is 81. 2 times 12 times 9 is 216 times the cosine of B. So the goal is going to be to isolate this cosine of B. So we need to remove these two pieces and bring them to the other side. I'm first going to add them. So 144 plus 81 is 225. And then I'm going to bring down the minus 216 cos of B. And I'm going to isolate some more by subtracting the 225. So 324 minus 225 is 99 equals negative 216 cosine of B. So to get cosine of B by itself, I have to divide by negative 216. And that's obviously not going to give us a pretty answer, but that's okay. So let's write it out here. We have negative 0.45833 repeated equals cosine of B. So now, if you remember, all we're going to do to solve for angle B is by hitting second cos in the calculator and putting in this negative 0.45833, remembering that second allows us to find the angle. So please remember second. So take a minute, type that into the calculator just the way that you see it, and then hit resume when you're ready for the answer. All right, so I got that angle B was 117.27, that if you round to the nearest whole number, or it says nearest tenth, excuse me, you would get that it's 117.3 degrees. All right. I know that was a lot, so if you have any questions as to why I did with what I did, especially in here, please jot them down and ask me in class tomorrow. I think we'll do examples 3 and 4 in class. I think the video is long enough. So that's it for tonight, and have a great night.